Hello guys, welcome to Masked IT. Today we'll be diving into a fundamental networking tool that you all might have used day in and day out while troubleshooting some scenarios at your company. This is a very simple tool which we generally utilize to check any sort of reachability issues or say congestion issues. So what is ping? Ping is basically a network command utility tool which is used to test the reachability of a host on an IP network. It basically measures the round trip time that a packet is taking from when it initiates from the source to the destination and from destination back to the source. If we dive into some history of ping, as you might have heard on my shorts as well, it was basically invented by Mike Muss at DARPA in 1983. And it was initially invented to check the reachability of the ARPANET network. Like we have a full form for ping, which is Packet Internet Grouper, and it was inspired by sonar sound waves. If we want to measure the distance from the source to the destination, what we do is that we'll emit the sound waves and wait for its echo to return, and then as per that we'll calculate the total distance of the object from the source. So how ping is able to achieve that? Ping generally uses an ICMP protocol in the backend, which helps it to send ICMP echo request to the destination, and then if the destination is able to pass that packet, it would be sending an echo reply. So inside that echo request, it contains various fields like identifier, sequence numbers. In the these identifier and sequence number contains a field named as indale. You'll be seeing in the captures BE and LE, which would be referring to big indale and little indale. Generally, we have nowadays only look out for big indale on the devices, but on some of the devices, for cross-platform communications to happen, we still have their little indale present over there. All right. So let's go ahead with how ping works. So when a user executes the ping command, what will happen is that it will send an ICMP echo request, and that request packet is sent to the target device. If it is in the same network, if it is on a different network, we'll be sending it to the gateway, and that gateway will be then, as per the route, it will be forwarding it to the target device. All right, so I have this small lab where I have router 1, router 2, and router 3. These two interfaces are on 10.1.1.0 network, and this one is on 10.2.1.0 network. Both are /24s. These are all freshly configured, and we'll be trying to ping for the first time from R1 to R3. And it succeeds. Let's try to see the captures now. All right. So if you see, these are the request messages. We see that the type is 8 and code is 0. That is for the echo request. And here we have two values of identifier and sequence number. Identifier BE means that identifier big ending, and identifier LE means identifier little ending. So suppose we have an identifier 0x 1, 2, 3, 4. So what big ending does here is that if the identifier is this, it will store the data like this, that 0x12 first and 0x34 later. If it is the little ending, it will store the data 0x34 first. It will store the data 0x12 later. In the big ending, it stores the most significant byte of the word at the smallest memory address. And in the little ending, it stores the least significant byte of the word at the smallest memory address. All right, then let's go forward. Generally, if it is a newly configured device, what will happen is that you might see a drop at the first packet. Why would it happen? So my packet was actually able to reach from router 1 to router 2. But here the router 2 does not have the MAC address information in its ARP cache. Generally, every router maintains a ARP table. What will happen is that initially when we have just configured the devices, it is possible that and we right away try to ping, we might see that there is a drop in the ping in the first packet. Why would that be? Because the router 2 would not be having the router 1's MAC entry in its ARP table. So generally we send ARP requests to understand that who is containing this IP, so that we can map its MAC address information on our in our ARP table in a particular network. All right, so that's why we were seeing the first packet as lost, and after that you will not see a packet lost there. So let's try to make some tweaks here. We'll what we'll do is that we'll firstly try to shut down this interface F00 and see what difference it makes. So I'll just quickly go into the interface and we'll do a shut here. All right, so now if I try to ping, it's definitely going to fail. But let's see in our captures what happens at this moment. So this one is going from R1 to R2. And if you see here, it says that no response seen. What does that mean? That my request was going till R1, but because of some reason, some vague reason, we can say it is not getting a response back to us because it actually it wasn't received by any router. So how can it respond back? Okay, so here the similar thing happened that my request did came out of R1 and reached till R2, but R2 did not receive it and dropped it because its interface was shut down, and that's why we are seeing no response C. Let's try to bring back the R2 up back again and try to ping, and it works. We'll do one more tweak. We'll go into another interface F1 by 0, and here we'll try to do a shut. All right. So what we did this time around is that in our topology, we have shut down this interface because at this point, it should be receiving this packet. So we should be seeing at least some response out of it. So let's try to ping it again. And you see this U over there, that host is unreachable. Why is it showing host unreachable? Let's try to explore it in the captures. All right. So if we see here, it sent a packet which says that no response seen. And just below this packet, we see a echo reply which says destination unreachable. Who's sending this echo reply? It is being sent by 10.1.1.2. Did we actually send the request here? No. But why it is sending an echo reply? Because ICMP in itself is a error finding protocol which tells us that if there is any sort of error on the line, and here our gateway to that network was 10.1.1.2. So it reached till 10.1.1.2 and it was able to it was not able to send the packet out because 10.2.1.1 through which it would have sent it out was down. So clearly the destination host was unreachable for it, and that's why we can clearly see that output here. Let's try to bring it back up and try to tweak one more thing. This time we'll try to shut down the end host, which would be our R3. So if we shut this down, what difference would it make? I think you might be knowing already by now because it would be same as when we turned off router 2's F0 by 0, that we'll not be getting any response. Why? Because the packets at this time would be would be able to go out of this F1 by 0, but would not be reaching F0 by 0 as it would not be able to receive those packets. And thus R2 was able to send the packet out, but it is not, R3 is not able to receive the packet, and that therefore we would be sending no response to the backend. So our packets are getting lost again. So in this case, again, we are seeing just ICMP echo requests over here and no replies. So I think this helps you understand that default behavior of ping. So I think we are clear with how ping works. So here are some errors that you might generally see while running the ping command. You might run this ping command on your CMD, on your routers, or on on a Linux, you can utilize it anywhere and it might give you some outcomes. Uh, yes, if in case ICMP is blocked by a firewall, you might not see it going past that. And in that scenario, you might see continuous failures. However, the destination was reachable on the TCP, but it's still failing for the ping. I have seen various scenarios in my experience where we try to check the reachability via ping, but the IP was failing to reach via ping, but it was able to reach if we use any other tool like testnet connection or a PS ping that generally utilizes TCP connectivity. So I would say that in such scenarios, always try to use a mixture of tools, just not don't rely on ping. But yeah, ping is a very useful tool to check the reachability. So we generally tend to use this as a first tool to check anything as in a network congestion or a unreachable scenarios. So let's try to see the errors. If you are getting a request timed out, you might see that the target device did not respond within the expected time frame. It could be due to the network congestion, target device down, unreachable, like RR3 was down, firewall or security setting block ICMP traffic. It could be also a scenario, or again, intermediate devices down. In that scenario, also we can see a similar scenario. Or whoever is a gateway is down. In that case, also we might see a similar scenario. Destination host is unreachable. This might be happen that if the local route or remote network device could not find a route to the destination IP address, like in our scenario where we tried to ping from R1 and R2's interface that faces the R3 was blocked. In that scenario, we were not able to reach R3 and we were getting host unreachable. So incorrect IP address or host name, routing issues in the network, target device is not connected could be the possible causes why we are receiving this. Unknown host. This is an interesting one. What happens is that sometimes we try to ping, say, google.com, and if you are not able to resolve the URL to the host to the IP address, then you might see that the URL was not able to resolve. Sometimes I have seen this scenario as well. Like for what happens is that if the client is having setup where he's trying to access storage or some app service, what he'll be doing is that he's trying to do the ping using the URL, but it is not resolving because they have not made the correct DNS entry. So it actually tells us that, okay, boss, you have missed out your entries, and kindly update your A records, or if you have any entries in your DNS servers, you have to update them, or you are not able to reach your DNS server. So at least it gives us an idea that where the issue lies. It's not lying on the connectivity, but it could be also lying on the resolution. Another failure, you might see that ping transmit failed with a specific error code, which the specific error code generally is returned indicating that there was a transmission failure. Say it is an error code 1 which says incorrect function, 2 says system cannot find a file specified, and so on. Like you can take a snapshot of this. This might be helpful while running the ping commands, and it would also help you while troubleshooting with this command. Going forward, I'll just do a quick recap that what all we had done on our lab. So we deployed our 3 routers. We just shut down our interface F0 by 0, and with that we could see that the echo request was going out and there was no response back from the server. At this point, we were seeing only 5 dots while sending the traffic out. Another scenario that we had seen was this one where we had shut down the F1 by 0 and rest of the configuration was up and running. In this scenario, we were seeing couple of U in the output, and this was because that the host was unreachable R1, and why that was the reason, because R2 was able to receive the traffic from R1 but and parse the traffic. It was trying to build the packet, but while sending it to 10.2.1.2, it didn't had the route to 10.2.1.2 because this interface was down. So only this interface knew how to send the packet there, and right now it's down. So we'll be sending a host unreachable to the source, that is R1. And that's why we see the source as 10.1.1.2 while sending the response back. And however, the request initial request had a destination as 10.2.1.2. So I think it might be clear with this. Third scenario that we saw was that R3 was down, and in this scenario, again, like our first scenario, we were just seeing the packet was going out. It was not sending back the responses. In this, we were not. We tried to take a capture on both. This between R1 and R2 and R2 and R3. And however, we were just seeing that the ICMP echo request was going out and there was no reply from the R3 and or R2 side. So that tells us that the packet was getting lost somewhere, as R2 was also able to send the packet out. It didn't generate it that the destination is unreachable to R1 in this scenario. All right, and our last successful one was that where everything was up and running, and in this scenario, we tried to calculate that what will happen in a working scenario. We also discussed regarding identifier and sequence number, what big endian and little endian means. They are generally there for cross like uh, cross-platform communications, and we can say diagnostic tools or custom protocols extensions. Uh, so because of that, we see BE and LE over there still. Okay. Other than this, these all were from the router, of course. And below, if you see, I have also pasted some commands from the CLI. Generally, we write ping the IP as it is. What will it will give is this. In the successful one, it will give me an output like this, that reply from 10.1.1, bytes equals to 32, time equals to 219 milliseconds, and TTL is equals to 61. So it tells me that how many number of hops it is far, what time it is taking to for the total round trip time from source to destination and destination to source, back to source. And this is the bytes that I am utilizing. In the non-working scenario, you might see a timeout and the other errors, of course, that we were discussing. Going forward, I would like to give you these commands that you may try at your end. If you want to try a specify a number of echo requests that your device source should be sending out, you can try to do it using -c or -n in Linux and Windows. If you want to do a continuous ping, as per my information, like till as far as I know, we can do it only via Windows, and you can do it with -t. Uh, if you want to set up a maximum time interval between two ping requests, you can use -i when you are using Linux. And if you want to specify timeout, you can write -w and timeout in seconds. And this command would help you out. I hope this was helpful, and the ping command is surely a powerful networking diagnostic tool used to test network reachability and connectivity issues. I hope understanding its key features and outcomes, you might better diagnose and fix network problems. And I hope this video might have helped you to make that understanding even better.